just try and if just remember in the whole vectors, I only know the cross and the dot product and also the magic triangle. These are the three I know. Okay, and then the rest is just applying it. You don't need to memorize a lot of things, but try and draw it if you are not too sure. So remember for a line, what is this lambda here? Lambda is your parameter. Is actually is a housing address. So every point on the line will have a different lambda. So can you tell me what is this lambda here? For this point here, this is lambda equals to 0. Yeah. So every point on the line will have a different lambda. This point will be correspond to 0. So you just let this be p lah. It's not an issue. Then what we need now is this is the direction. I just put this as the d direction here. We want a. A is above. I'm not sure where is it. So it's 3, 1 minus 2. So if you want to find the shortest distance here, okay, just remember you have a d here, and this over here is your perpendicular distance. So you know that this and this one here is what you have. So the angle between these two vectors will be here. So the opposite be A, P, cross with D vector. Okay, cross product, because it's opposite. Opposite corresponds to sine. Sine corresponds to cross product. The unit vector, the non-hypo. That's about it. That's all you need to know. So the shortest distance of A to L there you go. Okay, this part here will be just cross product lah. You can just copy mine lah. I know it's a lot of things to do, but you can go back and try. Part 1 done. Part 2 for the perpendicular. For perpendicular means we just need to find what is a lambda here which corresponds to this point here. Is it okay? Okay, so let this be n lah. Okay, let n be the foot of perpendicular. Let n be the foot of perpendicular. So essentially, this is the first step. For some lambda real value, on will take the line equation. Now it takes a line equation. Understand why it takes a line equation, because it's on the line. It's on the line, and you want to find the housing address which corresponds to this point here. So that's why for some, that's the first step. That's the reason why we put for some lambda, for some housing address which corresponds to that put a perpendicular there. We know that it is that like that. Okay, this is on. So anything with on, you just do that. This is step number 1. Step number 2 is we make use of an equation to solve for lambda, which is this 90 degrees. This 90 degrees here shouldn't be a surprise. This part here, what you need to know is, since put a perpendicular will tell you that angle ANP is 90 degrees, meaning to say AN dot with D is 0, because this is dot D lah. Or essentially, yeah, this is 90, dot product is 0. So ON, OA is the dot D, then you just Solve this. D will be okay. Just do this. Is you remember when I dot product, I usually just do this, just dot this. Give you this one, then you dot the other one. O-N. Some of the answer may be wrong. So if it's wrong, you just let me know. We can just work it out. So this is 0 minus 10 minus 10. That's an O-N. Anything to do with mirror image, please use ratio theorem. Okay, so it's not hard to see why, as long as you're on this earth and the photons are obeying the law of physics, then yes, you use mirror image. So it's A prime here is 1 to 1. So mirror image will just be by ratio theorem or midpoint theorem. So part 3, right? Or midpoint, O-N over 2. So O-N will be minus 20 minus 21 so this is the answer here. Okay, yeah,